Good evening to all. Welcome to day 6 online session. Myself, Dr. Shaik Mahammad Rasool, convener of this FDP. So let me introduce today's speaker for image cryptography in consensus algorithm blockchain. So none other than Sharma Venkatraman sir. So currently sir is working as a director, CR Rao, AIM SCS Institute of University of Hyderabad. Sir has retired from ISRO as scientist and group director. Venkatraman sir is working at Adrin Department of Space as a group director in the area of System Engineering Group. He has worked at Defense Electronics Research Laboratory for 5 years. He has worked at George Technology, Atlanta, USA in DoD project in artificial intelligence techniques for decision making. At Adrin Department of Space, he has been responsible in development of artificial intelligence techniques in satellite image processing and analysis. He was heading a group of scientists in the area of cyber security, solutions for data network and security. Software and embedded based security solutions have been developed for various projects. He has 34 years of work experience and more than 65 publications in international journals. Currently, SAR is working on development of blockchain platform and deep learning methods for real-time satellite imagery classifications. So this is a brief about today's speaker. Now I request Venkatraman sir to take over the session.
Thank you very much. And I think I have 45 minutes. How much?
Yes, sir.
50 minutes, sir.
Okay, thank you.
Yes, sir.
Okay, see, today's topic is a very, I don't know, you must be all exposed to what is blockchain. At least you must be knowing, most of them, all of them must be knowing something about Bitcoin. Okay, Bitcoin is just one derivative of a blockchain. Okay, one element of a blockchain. Okay, so today our topic composes different elements. One is, anyhow, the blockchain is there. Within the blockchain, there is an important concept called consensus. Consensus is a process where multi-party has to agree on a transaction. Okay, this is an element which is necessary in a distributed kind of platform. When you do something over a distributed kind of platform, there is no client-server architecture. A group of machines has to agree for a transaction to happen. That process is called consensus. And there are many algorithms available and many paradigms of consensus are available, like proof of work, proof of stake. Okay, like this, many are available. Okay, within that also, multiple algorithms are developed. Each one of the blockchains develop their own consensus methods. Okay, for example, in Bitcoin, the consensus algorithm says whichever machines which computes a hash value which is smaller than the previously generated hash value, that machine will be gaining the Bitcoin. Okay, that is the kind of algorithm, which is a tough algorithm, basically. So that is one of the methods of the consensus. Similarly, there are multiple blockchains. If you look at the resource available on the blockchain, there are about 800 to 900 kind of active blockchains as on today. Okay, one is the blockchain is an evolving kind of what we call new technology. That means it is just bubbling and not any person has adopted for any product, nor a solution is there which is running 24/7 given by any kind of banks or something like that. Okay, essentially it is just getting into its peak of its development. many pilot projects are there. Okay, but none of them as on today is a commercially running project, okay, to be talked about. Okay, in this, we will introduce how image processing or image cryptography. Okay, there is something called a cryptography. Cryptography is a subject where you handle any content which needs its confidentiality to be preserved. You encrypt it on one algorithm and either store it on this device or transmit over a network. Okay, so we have a new development called image cryptography, which is used in the consensus method. That is what we will try to talk about this in the next 40 minutes. Before that, I will introduce to you some of the new called the disruptive technologies. All of you must be knowing every 3-4 years, a few technologies make a lot of change of how the mankind, for the lives of the mankind, or for the kind of projects or the kind of attention of different engineering colleges, what kind of topics I need to teach my children, the children who are going to be passed out, to the job market. See, to look at, it's a good combination of artificial intelligence, blockchain, IoT plus 5G. Okay, everybody knows what each one of them, but there is a strong correlation between all of them, and each one of the technologies uses the other technology to make intelligent kind of processing or intelligent kinds of guesses or very smart way of operation. For example, in Internet of Things, the IoT platform, which means that from the sensors that are collecting the information which are fed to a microcontroller or a microprocessor, okay, the data gets logged, the data gets connected over a 5G network or any kind of wireless or a LoRa or something kind of a network, and then it is connected to the edge router. The edge router content is processed partially to whatever extent is possible. Some decision are made at the edge routers. Then the content again is passed through something called a fog computing. Okay, so multiple such sensors, when they bring data, the big data into a fog computing, okay, you can make a lot of decisions based on the ML and AI techniques or the DL and ML techniques, which are basically AI techniques, for making some decision making or taking some conclusions. Okay, and further, if you want to take much bigger kind of analysis or more number of systems connected, more number of networks into coming to place, the data flows into a cloud computer. From there again, you do a lot of processing. If you look at the whole kind of chain that acts from the sensors to the cloud, there are at least 4 elements which touches. One is the microcontroller, the microprocessor, which collects the data, which logs the data. Then the data moving to your edge routers. From the edge routers going to the fog computers. From the fog computers go to the cloud computers. Okay, the biggest problem in Internet of Things as on today is authentication of device. For example, let us say in the industry of health monitoring, you have a microcontroller or a microprocessor which keeps on logging your vital parameters like your BP, pulse rate, something like that. And somebody at the thousands of kilometers later, some doctors are looking at your parameters and taking some decisions. Let us say somebody replaces the sensor or the processor, what was supposed to be connected there, with some other thing. Okay, and you get if there is no authentication of that device which has been introduced, okay, you will get, or you may get into a situation where you are diagnosed for something for what you are not. Okay, or it could be something, the faulty equipment which is not collecting the data properly. You may be, and it's not authenticated on the network. You may get some results which are not consumable for you to take further action. That is the biggest problem of IoT, because the rate of IoT devices that grow as on today okay, is surpasses at least 20 times the growth of human beings on the network. Okay, so if tomorrow, let us say next 5 years, most of your bridges, most of your what you call health monitoring devices are all IoT devices. Then imagine the kind of problems that will create when authentication fails. That is where the blockchain comes into picture to handle the authentication. So blockchain, using the blockchain, you can authenticate all the connected devices and see periodically if some change, whether the device is changed or something happens to the device, a new device comes into picture, you have to re-authenticate the whole device and the whole chain before you collect the data. So essentially why I'm put this slide is all the technologies are related. Each one has got its own play in the whole network. Okay, the 5G, you know what are the kind of advantages, what kind of disruptive kind of applications will come out of the 5G. Of course, there are a lot of loopholes in the 5G transmission, which needs to be addressed, what we call as a wrapper application built over the 5G kind of communication, what we call protocols. Okay, this is what I just wanted to put as a slide, that is whole earth is going to be connected with a lot of IoT devices in all kinds of what we call applications, and each one collecting data at a different rate, different kind of what we call logging, and different kind of sensors being connected. The whole thing, nobody knows where they are connected, but you want some decision making to be done and the decisions to be transferred either back to the network or consumed for some kind of what we called predictive analysis or whatever it is. Okay, the top emerging technologies, as I told, just this keeps on changing every year. As on today, this year, it is most of the Internet of Things, IoT. Earlier IoT, they were all called M2M devices. If all the devices in the network are internet connected, then the whole network is called an IoT. Earlier, without an IoT, without an internet also, there were devices which are connected, monitored, all those, they were all called the M2M networks. Okay, so you can see the serverless computing being the fourth, the blockchain being the fifth, and sixth is the robotics. Okay, then you have the seventh, the biometrics. Eighth is called the 3D printing, okay, VR and AR, and the drones. Okay, this kind of rating on the top keeps on changing every year, but this is a circle of 1 to 10. Okay, now coming to what is the scope of blockchain in AI-enabled 5G technologies. One is the 5G framework trading. We have good amount of blockchain coming into picture. The distribution of the 5G networks, the roaming of the networks, and for the regulatory and the compliance is very important. For example, you find a rogue device of a 5G, through blockchain, you can actually take control of it and then not allow it to further contribute on the network. Okay, and you can take it what you call offline and subject to for validation and also the compliance. Briefly, these are the topics that I will cover next few slides. I will touch upon for completeness, what is a blockchain, what is a DLT. Okay, so distributed ledger technology is the word synonymous to a blockchain. Okay, we'll come to that. Then we will also see what happens in a blockchain network. What are the different components? How it happens? An important point is the consensus. Okay, which is a very important element. If the consensus algorithm is not very smart or not very fast, okay, then the number of transactions per second, the TPS, what we call, can vary rapidly, very, very slow or very, very high. Okay, why blockchain today, as on today, is not into the financial network? Basically because it doesn't mean the TPS rating required as per the Visa or a MasterCard, which makes about 22,000 to 40,000 transactions per second. You will not get that kind of transactions as on today with any one of the blockchain consensus algorithm. So that is a research area if you look at it. If you can make a very smart consensus algorithm, which will meet to the 22 to 30,000 kind of transactions per second consistently on a growing network, consistently growing, even expanding. Under expansion also the rate should not come down. If such a rates are possible, then there is a place of the blockchain on financial networks. Okay, so that is the reason, very strong reason, that multiple people are working on developing new consensus algorithms. And as on today, you get there are fooling around algorithms saying that I have what you called 15,000, 20,000, but they are not really true. In scalability, they fail. Okay, that is the main reason there are not good as on today enough products out of the blockchain. Okay, now for the consensus, I will be talking about what is the role of this image cryptography in consensus. Okay, before that, some of the terms I have to introduce to you. You must be knowing what is a hash function, what is a hash value. Hope, I think you must already, all of you must have been familiar with algorithms like MD5, SHA1, SHA2 or something like that. Hope so. It doesn't mean, it means that for any content, digital content, if you pass that content through a hash function, you will get a string depending on the algorithm, either a 256-bit string or a 80-bit string or a 128-bit string or a 192-bit string, depending on different algorithms. From that string is a unique representation of the whole content. The content can be few bytes, it could be few gigabytes or 1 terabyte, doesn't matter. But you will always get, that is why it's called a message digest. You will get a string which is exactly 256 bits. And that 256-bit string is unique. It cannot repeat or it cannot find another value for any other content. That is the importance, very, very important element. Whole of the blockchain runs on this principle that hashes cannot be reproduced. Reproduce means there is no collision of different content having the same hash. Okay, that is the most important element to see that the transactions are all unique. That is why it's called a DLT, distributed ledger technology. Okay, so you will be seeing that any content, for example, I am transferring 100 rupees from me to, let us say, your principal on the network who is on the, like a blockchain. Okay, this here, what I do is the construct between me and the principal is the address means the machine address means the IP address and the MAC address of the machine of mine. Okay, the MAC address and the zip of the principal, the wallet address of mine, the wallet address of the principal, and the 100 rupee or 100 tokens which I want to transfer. This is a string which I form. That string, we take a hash value. That hash value is what we pass through a consensus to prove that some, at least a few people out of the whole lot agree. That is why it is something like consensus is something like everybody did not agree. At least 2/3 of the people have to agree for this calculation. Then we transfer, then I transfer the 100 rupees over the network to somebody else, to principal or whatever. So that is what happens in a typical flow of what we call a blockchain. Okay, here I want to introduce a new concept called secret sharing. I don't know, you must be some of your lecturers, what we call the professors must have already done. There is something called secret sharing by Shamir. Okay, and there is also something called visual cryptography concepts, where any content that you compose, we convert that content into an image automatically, internally. It is an automatic process. That image is by a nonlinear function splits into multiple images, where no single image represents the whole content, but a group of such images, when you combine on a particular rule, you will get back the content. Okay, there is a principle of image cryptography, which we will be able to show you some of the slides. There is a new concept called storage called Interplanetary File System called IPFS. Okay, you must be knowing this is a distributed file storage system wherein, okay, we use a concept called Merkle tree to store the content. Advantage of doing this is the content is split and stored in multiple machines by itself. You don't know where they are stored. The Merkle tree keeps on tracking where the elements of the content are stored and recreates back the file. No duplication of the file is possible in this network. If we have one file, let us say you create a document called a1.pdf, and any number of times somebody wants to access or do something like that, only one file will be available for the a1.pdf even for 100 or 200 people. So duplication of the files is not possible, and you can update a file if you have the rights. Only the updated file will be available. If you want a previous version, you should store forcibly as a separate file separate. So essentially, duplication of the files is not at all possible on an IPFS network. This is a very important concept to hold the tokens of your blockchain on the network so that we can prove no duplicate two tokens are available on the networks. That means it eliminates as simple as duplicate currency notes, duplicate tokens are not possible. Okay, then we will introduce some new terms called what is quantum immunity, what is resilience. Okay, these are some of the words. I think I have another 25 minutes to speak. If somebody wants to put a question, you can put in the chat. Okay, essentially, the blockchain is a distributed network, as I told, and all kinds of machines can be connected on this network. The separate service on your TCP/IP stack on a particular port is run as a blockchain service. Okay, so you have something called user-defined ports in a TCP/IP stack. Every blockchain uses few of these ports to run their service. So the machines which are all connected on this port and which run the service, they all run a single blockchain. So that means you can see who is on the network, okay, on everything. But what you have to see, important element is, no person is known by his complete KYC. That means you don't know who is there physically on the machine. You only know by his wallet address. The wallet address is created without taking any personal information of anybody. That's most important. Okay, so everybody holds a wallet, okay, which is devoid of his KYC data. Okay, this is very interesting thing. That is the reason nobody in Bitcoin also, everybody is anonymous. Nobody knows anybody else by his name or his address or his phone number. Okay, everybody knows. Somebody has got a wallet address. If he's friend, you can put a nickname for him, but you know only his wallet address. Nothing else on the digitally on the network is known. Okay. Now, how does it? It is totally different from a client-side server architecture. In a client-server architecture, you have a server application, multiple clients connect to that. Then the server has got a database connection on the back end. So whatever services or whatever thing happens, the compute or the logic of decision making or something is a server component. Every client fills up the data or logs into his client as a browser. Okay, everything is completely determined by the server application. So there is a single point failure, which actually there is methods to handle it with multiple servers, all those things are there. But there are a lot of disadvantages in client server architecture. Okay, so essentially for banking applications, okay, this has got a big value because the transaction fee that you do with a normal kind of swift kind of transfer of a person living in let us say USA to transfer a content here, you pay a lot of amount on the transaction as a transaction fee. Also wait 48 hours to 72 hours to receive the amount. If this technology of the blockchain is used, it is instantaneous, meaning few seconds or few minutes. And the transaction fee is 1/100th or 1/200th, depending on the blockchain. He can operate at that low cost. Okay, and then there is a proof that you only received and somebody else did not receive. Okay, all these things are possible, and there is a record for anybody else to view. Or because this transaction is immutable, means you cannot erase a transaction. Okay, so distributed computer means all connected, fully connected, any number of machines on the network, irrespective of their compute power, whether it is a low machine or a very high-end machine or whatever it is, all of them run the same service. Okay, now if these transactions, whatever happens on the network, if you pile multiple transactions, okay, and then do one consensus, one element of consensus and create a record, that is called a block transaction. That is why it's called a blockchain. Okay, but in most of the banking applications, you require a transaction which is instantaneous. Okay, so one for every transaction, a chain has to be formed. That is why it's called a trans chain. Okay, so Ripple as a blockchain is more suitable for banking applications. But then a lot of difficulties in Ripple where it is not scalable. Okay, you must be knowing there are a couple of banks in India who have done a pilot study using Ripple for doing this kind of application. Okay, but then it did not take off further because scalability is a bigger issue. Okay, you must be knowing what is centralized, decentralized, and the distributed. You can see the distributed is a fully connected network. Okay, so this is the typical flow, what happens in a blockchain. Let us say person A is an individual who requests a transaction. Then a block of data is created, okay, to represent the transaction. The block is broadcasted on a P2P, means person-to-person network, consisting of computers known as nodes. All the computers on this connected to the blockchain, they are called nodes. So a group of such machines, you can the Bitcoin, whichever machine wants to at least 51% of the machines of the whole network has to do the work to do a transaction in a Bitcoin. But many other blockchains are there. For example, the blockchain that I have developed, you require only 21 machines on the network. Out of 21 means 2/3 of 21 only has to say yes for a transaction. Okay, so it depends on different implementations. Okay, then what is the network of nodes verify this is what happens and validate the transaction. The fourth element is the consensus process. Once that verification is done, what we call the transaction is combined with other transactions. That's what I told. You can stack multiple such transactions. After every 8 hours or 10 hours, you can create a block. But all the individual transactions within the block are also verified. So what only thing is that there's a committing, there's something called a commit of in a ledger. That happens after a few hours in a normal Bitcoin kind of blockchain. But many of the other blockchain, it happens instantaneously also. Okay, but the advantage of the Bitcoin only the currency portion of the blockchain, which we call as what we called as the tokens or the crypto tokens. That is the only application Bitcoin does, nothing else. But there are many blockchains which can be used for multiple other applications. For example, some of the blockchains like the Hyperledger doesn't have any tokens by itself. Okay, it can be used in many other applications. For example, supply chain management. Okay, any other applications you can build over the blockchain. Essentially, what blockchain is a network protocol, if you look at it. which is implementable by different people on different ports of the TCP/IP network, forming a set of rules which govern the blockchain. Okay, and this is different from each one of the blockchain. Each one of them have a place. For example, some of the blockchains are used for playing games. Some of the blockchains find applications in financial. For example, it can give you micro loans. Okay, that means somebody can say, I have 20 extra tokens with me, which I don't want to use next few days. I can lend it at a very low rate to somebody else for a few days or something. So you can have a flexibility on the number of days, flexibility on the amount of tokens that you can transfer. Okay, and the element, whatever fee that you want to fee rate at which it has to grow, those things are up to the individual to determine and give the loans. Okay, unfortunately, there is nothing as on today. You can buy an entity or a service using a blockchain in most of the countries, except few countries. So that is the main reason that many of the places still it is in an R&D stage, not in a full-fledged. Okay, so this is something like it will change the internet. Almost already you must be seeing that there's something called NFTs, Web3. Okay, all this kind of new browsers coming into picture like Brave browser. Okay, all these things change a lot. Okay, there is nothing, the client server architecture is going to vanish with time for most of these applications. Okay, these are the pitfalls. This can be obtained from any other book or something like that. Okay, essentially this is a distributed ledger, means it's an independent permissioned blockchain, can be as also a distributed virtual machines. Okay, you can write applications over the existing blockchain. They are called smart contracts. Okay, in databases, okay, people used to write what are called stored procedures. Okay, it must be relational databases. Stored procedures are the repeated kind of activity that you do on a set of tables, okay, on which you take some decisions regularly. Such kind of applications, if you write in a blockchain, they are called smart contracts. Exactly same, but a new word. Okay, so it all depends on the fully connected network. Okay, and you need to have a person active on the network to receive the transaction. So it is something like a chat application if you look at it. That right now it goes through a server and then it is connected. But without a server also you can have a multiple people chatting. You know when the other person is live, then you can also send some kind of information. Since multiple people can form in a group of, let us say, 100 nodes, every 10 different people can form a different cluster and keep on playing multiple games where all 10 people are involved. That is the reason this multi-party games on a blockchain, okay, or the metaverse kind of data, or as a which people use it for what you call playing games or whatever it is, that is getting popular. So new kind of such applications where AR and VR kind of combined methodologies for gaming are also getting popular on the blockchain. Okay, just to say there are two kinds of blockchain. One is called the permissioned ledgers. Permissioned ledgers means it works on a system of computers within a large office. For example, let us you have all the engineering colleges together can have one blockchain running, not with the external world, but on the internet like a VPN. Okay, all the engineering colleges together, you can have, let us say, called engineering blockchain, something like that. Okay, that means it works on a permissioned kind of network. It is not pervasive. The whole earth need not have the whole same blockchain. So examples are this Hyperledger, Ripple, okay, Tezos, and so many other things are there. There is called a permissionless blockchain. Permissionless blockchain, the Bitcoin is the biggest example. It's all pervading. Everywhere you can see the same network. Okay, irrespective of the place where you live, whole of the earth. Okay, the same kind of network will run. Okay, so this is useful for you to transfer the what you call interbank, intercontinental, what you call countries kind of transactions. All these things are possible. Okay, the same thing what I told, what happens on the network. Now I will come to the critical portion of the image cryptography. This is what says you can add any number of transactions, create a block and do the transactions. Okay, typical, what does a block contain? Is it always it contains the transactions that you want to do. A nonce is an what you call element which adds what you call to prove that no two numbers can become the same. We will add a random value to the nonce. Then the previous block, that is where actually the chain concept comes. The previous block and the new transactions combined together creates a new transaction. That is where the chain lock comes into picture. That is the main reason. If you do some kind of mischief on a new block after formation, the rest of the blocks will tell you who did the mistake, and you, the corrupt person can be caught. That is the reason in a blockchain, it is the ledger that is getting built and anybody can verify. So this is the biggest advantage for the banking industry. That is incrementally every day or few hours, you can create the ledger, you can do the verification of the ledger. You don't require separate audits, okay, when you put everything on the blockchain. So a lot of cost saving and instantaneous transfers are happening. Okay, typically any blockchain will contain, these are the different layers which I want to say. One is called, the bottommost layer is called the storage layer, because when you transact, you have to distributely store also. So for this, there is something called an IPFS network called Interplanetary File System. Why is called Interplanetary File System is, even if you have a storage on a moon or some other planet or whatever it is, the transaction times and the what you call things are all going to be the same kind of similar kind of seconds, few seconds or few milliseconds or few nanoseconds depending on the transaction. So wherever the storage is, okay, the transaction times are going to be similar. That is why it's called Interplanetary File System. Okay, there's nothing, it is not because of there are few servers or something in some other planet. It's nothing, doesn't mean that actually. Okay. Then there is something called a network layer, which I was talking about. The network layer is on the TCP/IP stack. As you know, for example, port 23, port 8080 are specific applications. Similarly, out of the 65,536 kind of ports, we have a good number of ports which are not used, and it's for the users to program or give a service on the network by themselves. So these are the ports that are being used by all the blockchains to do these transactions. Okay, then there is something called above the OS and the node layer, this runs. And there are some blockchains where tokenization is a must. There are something called a crypto tokens. There's called a KYC token or a DID token. There are something called asset tokens. So asset tokens are similar. The difference between the crypto tokens and asset token is, in crypto token, the value of the token is more important. It is, for example, I have an 100 rupee and you also have an 100 rupee. Okay, so the number of the token is not that important. The value of the token is important. But in asset token, the value is important. It is not the, every asset will have a different number. Okay, and it doesn't carry any value to it unless it is associated with the identity of a digital asset. For example, you have a digital book, e-book or something like that, and you want to cost it, let us say $53. When you attach a token to that $53 kind of entity, and you do all the smart contract on this token number, the token number doesn't change. That doesn't change at all. Any number of transactions you do. That is why it is called a non-fungible token. All crypto tokens are called fungible tokens. All what you call asset tokens are called non-fungible tokens. Okay, above that there is a consensus layer which I was talking about to you. Then everybody is identify a wallet. The wallet is the most important element of an individual who is on the network. Then there are multiple applications. This is where we give API calls for most of the people to build their own applications around this stack. So essentially, it is more like an operating system which runs, and then above that you can have tools and measures and applications written around that. Okay, so that is why we call this application layer and the contract layer are more for building applications around this whole stack. Is it clear about this? Now we will talk deeply on what happens to the. Okay, there are multiple ways called the consensus algorithms, proof of work, stake, proof of burn, proof of activity. Okay, then within that, there is something called lottery-based, voting-based methods. Okay, in proof of work or something of the sort, every piece of the node or different nodes have to do some kind of activity, do a computation and tell back all the neighbors of the whichever, let us say 7 nodes or 21 nodes, at least 15 nodes of the 21 nodes. That's called the PBFT rule. Okay, Byzantine fault tolerant rule. It says at least 15 machines have to report the calculations, what it has done. Once 15 of them say yes, that means the consensus is complete. For want of time, I'm skipping some of them. Okay, now this is what I told, the 3F plus 1 node and 2F plus 1 minimum has to tell yes. This is the Byzantine, what you call rule, which is normally done as an algorithm in any one of the blockchain where proof of work is an element. So essentially, let us say there are so many transaction nodes. Some of the nodes will have simple compute. Some of them have node for what you call computation, also storage. Okay, so let us say somebody in the network wants A to B, wants to send something. All these nodes will participate. So when these nodes participate, if are doing this piece of work, they also gain some points. For example, A to B, $10 or 10 tokens is being transferred. All the nodes which only do compute and give will get less kind of tokens. All the nodes which compute and also store on the IPFS, they get little more number of tokens. And the tokens, when they what you call add up to 10,000 or 10,000 or whatever it is, they can come and redeem 1 token from the network. That is how all the machines which are participating on the network, even when they are what you call, you are using the machines of somebody else which are on the network remotely, they also gain the money. Okay, now I'll go to the critical portion of the. Okay. Can you see a number 78FA3791? Okay, that number actually is a hash value of one of the transaction. That means I told you A to B, some construct is done. That hash value is that. Now what we do is this 78FA1, we internally create into an image. That means it's imprinted into an image. That image size is 768 by 27. Then we use something called a non-linear secret sharing algorithm, which says 1, 2, 7 means there is something called an essential share, which is 1. Then the total number of shares that you create is 7. Okay, at least two of the shares have to be merged to get back the original value. That is what it means, 1, 2, 7. The secret is split into 7 shares, where 2 shares can be combined to reveal the secret. Now a share is generated which will look as what we call the above. I'll show you that. Each share is above like this is a random image. Can you see that random image? Okay, this kind of data is being handled on every machine. This is the kind of thing, what you call, when you combine 2 of the shares, you will get back the original number. Okay, so this is an activity where you convert any content, the hash value into an image, and you play on the image domain to do all the calculations. Now, each of the share being so random, it won't reveal the whole content, any content of the whole content what you have seen, unless you know how to merge them and how to get back the content. Okay, these are the 2 shares. Okay, from where you get back the thing. So similarly, where you see, for example, each one of the image will be something like share 1 to share 7 or share 8, whatever the new algorithm of 3, 8. Here it means until you get the 3 shares out, 3 shares you merge, you will not get back the full image. Now, what happens is, let us say you have a transaction of transacting 20 tokens from a person to another person. That construct is constructed as an image, as a hash value converted image. This is what happens in the image thing. Advantage of this processing is, you can see the share 1 plus share 2 plus share 3, you will get back the, when I told the 1 plus the 3 comma 8. Okay, unless you have the share 1, share 2 and share 3 together, then only you will get back the image, which is the original kind of image that you created. Okay, so essentially, each share is given to each 7 nodes on the network, and there is an algorithm which says go and compute, okay, which is in something called the crux of the algorithm says go and compute at 64 different positions a combination of these pixels and element and show me that you are getting the result. That is the proof of work. Okay, able to understand? So you can see that some dots are there within the image which are colored. Those are the places some computation happens. Okay, for example, is the secret share 1 and share 2. Okay. Sorry. Okay, so share 1 and share 2 is combined by a nonlinear function. Okay, that nonlinearity is introduced when you create that algorithm. This function can be different for different implementations. For example, I am doing it for HDFC Bank. I will give a different function F1, Fn, which will be different from what I give to a HSBC bank. So no two banks will be able to what we call share the same data or replicate the same thing. Okay, the advantage of the whole thing is any content, for example, you create such a big image, which is a size of, let us say 6172 by some big value. Okay, what we call is the crack resistivity. The crack resistivity is a number which determines how complex is the image or the cryptography method by which you cannot break with the existing computers is on today. Okay, with this kind of applications, okay, you get a very high value. You can see that 2 power 319488. That is the kind of complexity for which we have to do with the computers available. Okay, which is even with quantum computers, you cannot break this kind of image cryptography. Whereas with existing ECC method on the PKI or the RSS methods, whatever you have only 2 power 4096. Okay, which also cannot be broken as on today. But when the 8 qubit kind of computers come into picture, they can be broken in few seconds. Whereas even with the 2 power 319488 kind of entity, what we do, you will not be possible even what we call next few what we call hundreds of years for you to break this kind of cryptography. So this is the most critical element to show that all the algorithms that you build with image cryptography in place, okay, for an application like blockchain, the crack resistivity of the algorithm is so high, even quantum computers cannot be used for breaking it. Okay, so compare RSA 4096 with our 2 power, it's 95 in case it's a color image, 368, you can see the kind of difference. So this algorithm is being subject for the NIST community in US, okay, to tell that it will be one of the future of the quantum, post-quantum, what we call algorithms, which are going to be immune for this kind of transactions. Next few years, maybe 20 years, the existing money transfer. Okay, I am done. And if any questions are there, I'll be able to take it.
Yeah, I request participants, if you have any queries regarding this topic, you can ask the questions here.
Somebody on the chart have put how to maintain previous block hash storage. Okay, that is the previous transaction would have already kept that element. Actually, you don't have to worry about it. Every transaction, as I told, is a combination of the previous hash value and the next hash value. So previous block would have contained that hash value itself.